introduced in the foreground, it considers an object, and this is how our program sees it, and then we proceed to detect this white part and draw a rectangle around the object. One of the problems was that all the tracking detection algorithms out there usually don't work for small objects. This is actually one of the bigger objects we detect. You can detect a lot smaller than that, down to around 2 inches. The detection algorithms out there kind of only work for cars and people. It's very easy to detect large objects. You can do subtraction method previously in last week. So it was difficult for us to find an algorithm that would actually work for small objects because all the ones we previously tried simply ignored anything small, just like nothing was there. We used OpenCV, by the way. It's an open source computer visuals library. We used it with C++, so this was our environment. And we got pretty nice results. We hoped to do more, but I guess we were constrained at the time. Any questions?
What platform did you use? Process perspective?
Oh, Windows.
Windows, okay.
Is it, I mean, is range your detection?
How far can you detect? Currently, we tested it in our room. We got up to, let's say, 12 feet. We can probably go up to, I'd say, it really depends more on how small the object becomes. It doesn't matter how far it is. So I would say as far as the limit on size, maybe an inch, up to 1 inch big, as far as you can see on the screen.
What other type of technology did you evaluate other than this particular one before you decided?
You mean detection algorithms?
Right.
We used the main one, the first one we used a simple previous frame, current frame subtraction, which yielded really, really bad results and only tracked large objects. We then used something called the histogram method, and what that one does is it analyzes every pixel for its hue, saturation, and I think Matt can explain it a little bit better.
OpenCV has a method to compare two histograms and it returns a number. And we return a lot of noise, so it's hard to find a number range to give us the right value we wanted. So we went with this background method to give us better results.
So yeah, it finds like the difference in hue and saturation of each pixel, and when something new is introduced, that histogram changes, that value changes, and the difference between that tells us whether there's an object introduced or not.
Is the motion cause you problem or give you false positive or?
Originally we had a lot of problem with false positives, so what we did was we essentially did post-analysis. After something is detected, we determined, okay, if it's too large, then we probably can ignore it. There's a car passing by, for example, because it's an airport runway, so people are going to be walking by, cars, airplanes. It ignores anything that's too large and only detects smaller objects. We can also add to where, let's say a bird flies by, it's small enough to be detected, but it's going to be gone so fast that we can just tell the program to ignore it. Unless something comes into view and stays in view, then the program just ignores it.
But this is all algorithmic, not hardware based.
Yes, this is all programming. Also another thing was, after something's detected, let's say it sends an alert to the operator, and he determines whether it's dangerous or not, sends someone to take it out. If it's not, you can simply upload, what's called, refresh the master image, and now whatever object was there is just considered an